For the first time in human history, humanity is no longer only observing the solar system from afar. We may be witnessing something far more extraordinary, a traveler from another star system moving through our cosmic neighborhood. Across the immense darkness between stars, countless fragments of rock, frozen ice, and ancient planetary debris drift silently for millions of years. Most will never encounter another world. They wander endlessly through interstellar space, unseen and forgotten. But occasionally, by a rare coincidence of motion and timing, one of these objects enters our solar system and changes the way we understand the universe. Now, a newly discovered interstellar visitor known as 3I Atlas has captured global attention. Identified as only the third confirmed object ever observed arriving from beyond our solar system, it immediately challenged scientific expectations. Unlike ordinary asteroids, it does not appear entirely rocky. Unlike familiar comets, it does not behave in completely predictable ways. Instead, it seems to exist somewhere between categories, an object that may force astronomers to rethink what interstellar visitors truly are. Humanity has only recently begun studying such objects. Before this discovery, only 2 confirmed interstellar travelers had ever been detected. The first, Oumuamua, appeared in 2017 and shocked researchers with its unusual shape, dramatic brightness changes, and unexplained acceleration as it departed the solar system. Years later, scientists still debate exactly what caused its strange behavior. Then came Borisov in 2019. A much more comet-like visitor that carried material formed around another star. For the first time, humanity was studying matter born in a completely different planetary system. But 3I Atlas may be revealing something even more mysterious. At first, astronomers believed it would be another routine flyby, a brief appearance before disappearing forever into interstellar darkness. Yet as telescopes gathered more data, the object began displaying behaviors that raised new questions. Comets normally react to sunlight in predictable ways. Heat causes frozen material to vaporize, releasing gas and dust that slightly alter movement. These effects are well understood. But this object appeared less cooperative. Researchers noticed irregular shifts in brightness and subtle changes in motion that did not always match traditional models. Some activity appeared uneven, almost structured, as though hidden processes beneath the surface were controlling how energy and material escaped into space. Infrared observations revealed fragmented streams of gas and dust rather than the smooth coma expected from typical comets. Brightness increases often matched sudden bursts of activity, suggesting a deeper internal complexity. Spectroscopic analysis added another layer of intrigue. The object appeared rich in carbon compounds, silicate particles, and volatile materials uncommon in our own solar system. These signatures strongly suggest it formed around a distant star under conditions very different from those that shaped Earth and its neighboring planets. In essence, this traveler may be carrying the preserved chemical memory of another world. And yet, some observations remain difficult to explain. Certain changes in motion appeared without obvious outgassing or visible jets. While most scientists continue to support natural explanations, the persistence of these anomalies has made the object one of the most intensely studied visitors ever observed. Rather than simply passing through our solar system, 3I Atlas has become a moving laboratory, one that may reshape humanity's understanding of interstellar space itself. The arrival of 3I Atlas may prove important for far more than astronomy alone. It could help humanity explore one of the oldest and most profound questions ever asked. How did life begin? And could the ingredients for life travel naturally between stars? For decades, scientists have considered the possibility that interstellar objects may act as cosmic carriers, ancient travelers preserving chemistry from distant worlds across unimaginable spans of time. These objects drift through the galaxy for millions, sometimes billions, of years, surviving in the freezing darkness between stars. Locked inside their layers of ice, rock, and dust may be complex organic compounds formed long before Earth even existed. Some researchers believe these materials could include amino acids, carbon-based molecules, and other ingredients connected to prebiotic chemistry, the early chemical processes that eventually made life possible on our planet. If that idea is correct, then every interstellar visitor entering our solar system may be carrying a chemical record from another corner of the galaxy. Every burst of gas escaping from 3I, Atlas, every cloud of dust released into space, could contain matter forged around another star system entirely. In a sense, objects like this become messengers from places humanity may never directly see. This possibility connects closely to a fascinating scientific concept known as panspermia. The theory suggests that the building blocks of life may spread naturally throughout the cosmos aboard asteroids, comets, and interstellar debris. Rather than life emerging in complete isolation, the essential chemistry for biology could migrate from world to world over cosmic timescales. While panspermia remains unproven, discoveries like 3I, ATLAS make the idea increasingly difficult to dismiss outright. If fragile organic compounds can survive radiation, freezing temperatures, and immense journeys through interstellar space, then perhaps the seeds of chemistry are not rare at all. Perhaps the galaxy is constantly exchanging material between stars, quietly distributing the ingredients for life across countless planetary systems. That possibility changes the way humanity sees itself. Earth may not represent an isolated biological miracle hidden within a lifeless universe. Instead, our planet could be part of a far larger cosmic network, a system where chemistry, water, minerals, and organic molecules move naturally between worlds over millions of years. In that view, life on Earth may be connected to processes much older and larger than humanity has ever imagined. But the significance of 3I, ATLAS extends beyond chemistry and biology. It may also reshape the future of exploration itself. Until recently, interstellar objects were mostly theoretical. Humanity assumed they existed, but no one knew how often they entered our solar system or what they might look like. Now, with multiple confirmed detections within only a few years, scientists are beginning to realize these visitors may be more common than expected. Future generations may not simply observe them through telescopes. They may attempt to intercept them. Space agencies are already discussing missions designed to chase, photograph, and perhaps even sample future interstellar visitors before they disappear back into deep space. But if objects like 3I, ATLAS possess unstable surfaces, hidden cavities, or unpredictable outbursts of activity, then such missions could become extraordinarily challenging. Spacecraft may need autonomous navigation systems capable of reacting instantly to sudden changes in movement, rotation, or material eruptions. Interstellar exploration may demand technologies far more advanced than those currently used for ordinary asteroid missions. Yet perhaps the deepest impact of 3I, Atlas is not technological. Perhaps it is philosophical. Again and again, the universe reminds humanity that reality is far stranger than expectation. Every time science believes it fully understands the cosmos, something unexpected appears, forcing old assumptions to be questioned. Interstellar visitors are powerful reminders that the solar system does not exist in isolation. It is part of a much larger galactic environment filled with wandering objects, ancient debris, and histories older than Earth itself. Each of these travelers carries evidence from another place, another star, another planetary system shaped by conditions humanity may never directly witness. And that realization changes something fundamental. It expands our sense of connection to the universe. Eventually, 3I, ATLAS will continue its journey outward. Its path will carry it beyond the planets, beyond the influence of the sun, and back into the silent darkness between stars where it may wander for millions of years before approaching another system. But it will not leave empty-handed. It will leave behind questions. Questions about planetary evolution. Questions about the chemistry of distant worlds. Questions about how matter travels across the galaxy. And perhaps even questions about the true origins of life itself. Maybe objects like 3I, ATLAS are incredibly rare. Or maybe the galaxy is filled with countless unseen travelers crossing the darkness between stars every single moment. Either possibility is extraordinary. Because the deeper humanity looks into space, the clearer one truth becomes.